Hello, everyone. In this video, I will be going through some R functions that can help us when we are dealing with discrete random variables. Now, I just want to say I am not going to be explaining any of these concepts. I am just going to show you the functions and how to code it in R. I do encourage you to look at notes or maybe other YouTube videos or any sort of resource to actually familiarize yourself with these probability concepts before watching this video so you understand what we are doing. So R has the ability to calculate probability mass functions. Remember, when we're talking about discrete random variables, we're talking about probability mass functions. And when we're talking about continuous random variables, which is a different YouTube video, we are talking about probability density functions. Anyway, R has the ability to calculate both of those. Also, it has the ability to calculate cumulative probabilities, quantiles, or otherwise known as percentiles, and then finally generating random values from a given distribution. These are the four different functions that we're going to explore today, and we're going to explore these four functions looking at the Poisson distribution as well as briefly the binomial distribution. So let's get started. Now, the first thing that we're going to talk about is calculating the probability mass function of the Poisson distribution. That's what, or of a Poisson random variable, sorry, that's what we will start with. What you'll find is when it comes to these four different types of functions that I just mentioned, they're all going to have the exact same prefix, but what distinguishes which distribution we're going to be using is the suffix that is used. So with the Poisson distribution, the suffix is going to be POIS, P-O-I-S. And then the prefix determines what we want to do, whether that be calculate the PMF, calculate the cumulative probability, calculate a percentile, or generate random values. Like I said, we're going to start with the PMF. Now, the prefix for this is just the letter D. So the function, when we put this prefix together with the suffix, is going to be D plus. And the different distributions are going to have different arguments. But the first argument is always going to be what value of X we want to calculate. So the PMF is represented by P at X. This is going to be whatever that X is. So in other words, here we are calculating Px, which is just equal to the probability that X is less than, or sorry, X is equal to X. Got a little bit ahead of myself there. So in order to calculate this probability, we use the D plus function. Say we want to calculate the probability that our random variable X, which we know follows a Poisson distribution, is equal to 3. And we know that the Poisson distribution takes the parameter lambda in its PMF. So in order to calculate the PMF, we also have to specify a value of lambda. And let's say that is 2. So if we run this, we'll see the resulting probability in our console down here. And this probability is equal to 0.18. So what are we calculating here? We're calculating the probability that X is equal to 3 when lambda is equal to 2. And of course, we can change the value of X. We can change the value of lambda. And that gives us a different probability. So the prefix D corresponds to calculating the PMF. When we want to calculate the cumulative probability, which, as I mistakenly wrote before under the PMF, this is the probability that x is less than or equal to a value x. We use the prefix p. So here, p Poisson, so the cumulative distribution of, or the cumulative probability from the Poisson distribution. Again, we need to specify what value of x we are considering here. So we want the probability that our random variable x is less than or equal to 5. We'll do q equals 5. And our lambda here, we'll set it equal to 2 again. So this gives us the probability that the random variable x is less than or equal to 5 when lambda equals 2. So we run that and we see that this cumulative probability is about 98%. Something that I want to note here is that in R, when we use this P Poisson or P whatever other distribution we are considering, this calculates the probability that x is less than or equal to a value x. If we want the probability that x is less than a value x, when we're working in a discrete distribution, this is just going to be equal to the probability that x is less than or equal to x minus 1. So, for example, if we want to calculate the probability that x is less than 5, this is going to be equal to the probability that x is less than or equal to 4. Because this is a discrete distribution, we can do this because we know that with a discrete distribution, the support are just those finite or countable numbers in a set. So if we're doing this, again, P plus, we do Q equals 4. We'll do lambda equals 2 again. And then we see that the probability that x is less than 5 is about 95%. One other thing that I want to note is that with cumulative probabilities, this just means that the probability that we have a random variable x less than or equal to a certain value x. But what if the question that we are interested in is what is the probability that our random variable x is greater than a value x? With this one, we have to think back to our probability rules, specifically rules about complements. If we think back to set theory a little bit. So the complement is going to be the probability that x is less than or equal to x. And we know that when we add those two probabilities together, we're going to get 1. So the probability that x is greater than x is going to be equal to 1 minus the probability that x is less than or equal to x. And like I said, this just comes from the complement rule. Both of those probabilities are complementary to each other because they make up the entire space. We have a random variable x, everything greater than a certain value x, and then everything less than or equal to that value x. That's going to make up all of the possible values. So together, when we add those two probabilities, the probabilities of those two events will equal 1. So if we do this as an example, say we want the probability that x is greater than 2. This is going to be 1 minus the probability that x is less than or equal to 2. So we get 32%. Now, we've covered PMFs, we've covered cumulative distributions or cumulative probabilities. Now, the third function that we're going to cover is percentiles, aka quantiles. You'll see them named as both things, percentiles or quantiles. And because P is already used as a prefix, here we use Q to match quantile. So Q plus will give us a quantile. Here we put in what quantile or percentile we want. Say we want 0.9. And again, we need to specify the parameter of our Poisson distribution, the lambda. So if we want the percentile, the 90th percentile, here, this gives us the integer such that, so the result is the smallest integer, x, such that the probability that x is less than or equal to x is greater than or equal to whatever we assign our value p to. So this is going to be 0.9. So in addition to just putting one value as the percentile, we can put a vector. So if we want, say, the 30th percentile and the 75th percentile, the result is down here. We get two values, one which corresponds to the 30th percentile, one which corresponds to the 75th. Now, the last function, which is a great tool when it comes to random variables in R, is generating random values from a distribution. And the prefix of what we use for this is just the letter R. So to do so, we say R plus, and we need to specify how many random values we want. And of course, we need to specify that parameter in the Poisson distribution. So down here, we see that we get 10 values that are randomly generated from a Poisson distribution. And we can increase our n, and we see that all the results are just put into a vector. That is the Poisson distribution. Like I mentioned, with any other distribution, it's going to be the exact same four prefixes, P, D, Q, and R. I said those out of order in which we did them, but you get the gist. But what is going to differ between the distributions is the suffix that's used. So with the Poisson distribution, we use the POIS, the POIS suffix. With the binomial distribution, we use the binome suffix. So with the binomial distribution, the suffix is binome. And because the binomial distribution takes different parameters compared to the Poisson distribution, the arguments in the function are going to be a little bit different. So if we're doing D binome, for example, we can see that the x stays the same because this is just going to be the probability that our random variable x is equal to some value x. But here we need to include the size. So this is like the size of our experiment, our sample size, as well as the probability of success. So here, say we want the probability that our random variable x is equal to 20, when our sample size is 100 and our probability of success is 0.1, so 10%. And we see that we get a probability down here. Now, if we want the cumulative probability, it's the exact same thing. So we put in our value, say we want 10. Our size is going to be equal to 100. So this is our sample size. Our probability, again, we'll leave that at 0.1. And this is going to give us the probability that our random variable x is less than or equal to 10 in this situation. And our probability is shown in the console. Again, this feels a bit redundant, but I'll just do this for completion purposes. When it comes to the quantiles or the percentiles, same function, q binom. We put whatever percentile we want, the sample size, and our probability of success. And we see that quantile in the console. And finally, we have our binom, where we generate random values from a binomial distribution. This part is tricky, so it's very important that you remember that in the arguments of the R binom function, we have n, which is the number of values we want to generate, and we have size, which is the sample size of our experiment. So sometimes in textbooks and course notes, you'll see that the parameter with the binomial distribution that corresponds to the sample size is also called n. But when we are coding in R, remember, R binom, that n is the number of values that we want to generate. So say we want 10 values, our sample size is 100, and our probability of success is 0.1. We get those 10 random numbers in the console. Now, that is everything that I have for discrete random variables. If you haven't already, there is another video that goes over continuous random variables where we talk about the normal distribution and briefly touch on the continuous uniform distribution as well. Thank you for watching.